On this page of notes, we have a really short page. It's mostly a concise description of what we talked about on our previous page, so hopefully it will all make sense and we can go through this very quickly. What we're looking at the top part of the page here is the terminal voltage that the battery actually produces in relation to the current or the amps that flow through the battery. So make sure you get in here, the I here are the amps flowing through the battery. Okay. We can see that when the internal resistance, that little r, is non-existent or negligible, if it goes to 0, then we get the terminal voltage equals the EMF, and no matter how many amps we have going through our battery will behave according to the voltage that is there. So that's ideally what we want. No matter how the battery works, we want the EMF voltage to remain steady. Now, if our battery is not as efficient as that perfect assumption, here's what happens. So this is what we want to see, that as the current flows in an actual battery, the internal resistance plays a greater and greater role the more current that we're drawing from the battery. The more current we draw from the battery, the terminal voltage, the actual voltage that we get to use from the battery, reduces. So VT gets smaller as I gets bigger in an actual battery. So that's the most important thing for us to see out of this top page of notes. And again, for our analysis, we'll often be taking that little r equals 0 going forward, but I wanted to make sure up front in the notes you understood what would happen if heat is generated. So this should go very quickly because we've already talked about it. We have the discharging case. So I just have this here as kind of a summary of the discharging case. We don't want to have to go through the whole analysis we did on our previous page to really just write down that the terminal voltage, we hope, should equal the EMF voltage, but will be a little less based on the internal resistance when we're using the battery. And when we, of course, hook it up to a charger, we see that we will temporarily get the terminal voltage to be bigger than the EMF voltage by this amount IR as we drive the process in reverse. So as I said, really short page of notes. I'm going to zoom out here, let you pause it, copy down what you need, and we move on.